Hi, this is a continuation of our lecture on constructions. If you had seen the last lecture, we had ended with this, that is constructing a triangle given its base, a base angle, and the sum of the other two sides. We have some additional comments that we wish to make regarding this construction. There is an alternate way you can do this. That is, instead of drawing this angle, what we can instead do is simply draw the perpendicular bisector of CX. So we could have obviously, the way to draw perpendicular bisectors. That was the second construction we discussed, and so therefore draw the perpendicular bisector of by obviously taking the arcs, etc. Draw the perpendicular bisector of CX, and this this point of intersection of BX and the perpendicular bisector will in fact give you point A. The justification again refers to isosceles triangles and is pretty easy. We invite you to look into the proof. Okay, now let's look at construction number 5. That is to construct a triangle given its base, a base angle, and the difference between two sides. So let's just start off by calling the triangle ABC, ABC, and let's say the given angle is angle B. So angle B is given, and we know the difference between the two sides. So when you talk about difference, it can be obviously two cases. Uh, we'll start off with a case where AB is greater than AC. That is the first case, and we'll talk about a different case in which AC is in fact greater than AB. Right. So we'll focus on this case first. That is AB greater than AC. This implies AB minus AC is greater than 0, and AB is equal to AC, sorry, AB minus AC, and that is equal to A, which is in turn greater than 0, given. Right? We'll discuss this case after we're done discussing this one. So first of all, start with base BC, then draw out the difference. First obviously draw out the angle. This is a ray, and this is the angle theta. Let's just say angle B given as theta, right? And using your compass and A as the radius and B as the, let's just call this point X, and B as the center, cut out A, and let's call this point D. So BD is equal to A, right? So now what needs to be done is join D and C. So join DC, right? And now draw the perpendicular bisector of CD. The perpendicular bisector of CD, obviously we discussed in construction number 2 how to draw perpendicular bisectors. That is by taking the radii and cutting arcs on two sides. I'm doing this in rough obviously, but you get the gist of it, and draw the perpendicular bisector. Let's say that the perpendicular bisector intersects uh, this ray at point, let's just call this point P, we'll talk about this later, and join PC, and so this is 90 degrees, and this side is equal to this side, and also this side is common, and so therefore by, if this were point O, by SAS triangle POD is congruent to triangle POC, triangle POD congruent to triangle POC, right? And so therefore DP is equal to PC, dP is equal to PC by CP/CT. dP is equal to PC. And so we notice that these two sides are equal, and I would like to claim that this point is in fact point A. We can actually call this point A. And let's see how the justification goes. We have AD plus DB is equal to AB and AC is equal to AC. Now subtract both these, so we get AD minus AC plus DB is equal to AB minus AC, right? So this is equal to A, and this also is equal to A, and AD is equal to AC. That is what we used to call P is now A, so DA is equal to AC, and so these two cancel, and so therefore this statement reduces to an identity, and so therefore ABC, triangle ABC is the required triangle, right? Let's just look at the case where AC is greater than AB and not the other way around. So we're now looking at a case where AC is in fact greater than AB, and let's call AC minus AB equal to A, and this is greater than 0. So as usual, we'll start off by drawing the base, which is BC. We'll draw out the base angle like so, but this time extended backwards, extended this way also. So this is equal to theta, right? And we extended it backwards. Let's name this ray X. And so now what we need to do is, instead of taking the arc which has radius A and cutting on this side, cut on this side. So therefore, with the compass with radius A and center as B, cut on the other side of the line segment of the ray actually. So let's call this point X, and Bx is equal to A. Bx is equal to small a. Notice the crucial difference here. We were cutting here, that is cutting where on what we would call the positive side of the angle, but this time for the case where AC is greater than AB, we'll cut on the other side, and so therefore Bx is equal to A. Let's just rename this point as P, because this is already X. So BP is equal to A. No mistake there. So BP is equal to A, and now what we need to do is join P and C. Join P and C, and again take the perpendicular bisector of PC with the method discussed in the second construction. So draw the perpendicular bisector of PC. Let's just call this the perpendicular. Sorry, that doesn't look like the perpendicular bisector. We'll draw that again. Draw the perpendicular bisector. Obviously, I'm drawing it by some estimation, but you need to do that with the construction discussed in construction number 2. So draw the perpendicular bisector and name the point that it cuts on Bx as point A. I claim that this is point A, in fact the point that we need, and we'll see the justification later. And so join AC, and triangle ABC is the required triangle. How do you do that? Again, the answer is pretty easy. We have AP is equal to AC, AP is equal to AB plus BP is equal to AC. We know that BP is equal to A. So replacing BP by A, we get A plus AB is equal to AC. This implies AC minus AB is equal to A, small a, hence proof. So that was our justification of this construction. Use this construction where AC is greater than AB. Now next and the last construction we'll look at in this lecture is how to construct a triangle given its perimeter and its two base angles. This construction will use some of the constructions we have discussed earlier. Say the required triangle is triangle ABC, and say AB plus BC plus CA is obviously given, and let's just call it A is given, and let the base angles, let's just call BC as the base, and so we have angle B is equal to theta and we have angle C is equal to phi, which are both given, right? So how do we start? We start with a construction of a line segment XY such that XY is equal to A. XY is equal to A. We start with this. This is X, this is Y. Next up, draw the base angles on either sides. So this is a ray, let's just call it say P, and this is equal to angle PXY is equal to theta, and on this side let's call it Q, angle QYX is equal to phi, right? This angle is phi. Next, with the construction discussed in the first construction, bisect angle PXY, and say this is the angle bisector. The angle is kind of small, so okay, well, let's just draw this again. We have to draw the angle bisector of angle PXY. Say if this were the angle bisector, extend it as much as you want, and say we call it point N, arbitrary, and also bisect angle QYX, bisect angle QYX, and look at this point. We'll call this point of intersection A, and we'll justify this later on. And now draw the perpendicular bisector of XA. Perpendicular bisector of XA using the second method discussed. And if this is the perpendicular bisector, so obviously the 90 degrees. And let's call this point B, and do the same thing with AY and draw the perpendicular bisector. Say if this were the perpendicular bisector, and we'll call this point C. Now obviously join AB and AC. Right. Let's look at the justification we have for this. We have this as the angle bisector, so this is equal to theta by 2. This will obviously be theta by 2, and so therefore, because angle ABC, that is angle B of the triangle ABC, is the external angle of triangle XBA, this angle in fact equal to theta by 2 plus theta by 2 equal to theta. And the same thing, same train of logic is true for this, and this is equal to phi. Also, look at XA, because this is the perpendicular bisector. If this were point O, this XO is equal to OA, and theta by 2, so this side is equal to this side, and with the same train of logic we have this side is equal to this side, and so therefore XB is equal to is equal to AB. We have XB is equal to AB, and also YC is equal to AC, right? Now because XB plus BC plus CY is equal to XY is equal to A. Now replace XB by AB and YC by AC. So we have AB plus BC plus AC is equal to A, which is what we had started off to draw. So triangle ABC is the required triangle. So this is all we had to say about constructions. In constructions, practice is very important, and sometimes things get tedious like this one. And because I didn't have the aid of a compass, I did the best I could. But constructions is pretty easy if there's enough practice. Especially practice is required in the cases of drawing general angles, etc. This is all from us. Thank you.